We're looking at homework from section 2.1. This is question number 20. Construct a frequency distribution and a relative frequency histogram for the data set using 5 classes. Which class has the greatest relative frequency and which has the least relative frequency? And we have a set of 24 lengths of adult Fijian banded iguanas and their lengths. So first we're going to find the class width, because to build any kind of frequency distribution, we need the class width. The formula for the class width is maximum minus minimum divided by the number of classes. The maximum data value here is going to be 73, and the minimum is 52. So 73 minus 52 is 21. We divide that by the number of classes, which is 5. 21 divided by 5 is 4.2. With class width, we always round up to the next highest integer, which is going to be 5. So the class width for this set of data is 5. Then let's go ahead and build our frequency distribution. We need to define our classes. To define our classes, the first class always begins at the minimum data value, which is 52. Then we add the class width to get the next lower class limit. So 52 plus 5 is 57. We add 5 again, which gives us 62. Add 5 again, that gives us 67. Add 5 again, that gives us 72. So those are all of our lower class limits. Then for the upper class limits, each upper class limit is one less than the next lower class limit. And the upper class limits also differ by the class width. So the first upper class limit is one less than the second lower class limit. The second lower class limit is 57. One less than 57 is 56. Then we can add the class width of 5 to get subsequent upper class limits. So 56 plus 5 is 61. Add 5 again, 66. Add 5 again, 71. Add 5 again, 76. So now we have our classes defined, so we'll go through our data one at a time, putting them where they belong. So 52, 66, 69, 55, 66, 61, 69, 67, 68, 62, 54, 70, 56, 61, 73, and 62. 62, 58, 63, 59, 62, 67, 63, and 61. So those are the 24 data values. Now we can go ahead and add up each of those tallies to determine our frequency. So we have frequencies of 4, 5, 8, 6, and 1. Now it's a good idea at this point to add up the frequencies to make sure that they add up to the total number of data entries that we have, which in this case should be 24. 4 plus 5 is 9. 9 plus 8 is 17. 17 plus 6 is 23. And 23 plus 1 is 24. So we're on the right track. To determine relative frequency, we're going to divide each of the frequency values that we found by the total number in the sample, which is 24. So for the first relative frequency, 4 divided by 24 is equal to 0.167 when we round off to 3 decimal places. And all values in this table will round off to 3 decimal places. 5 divided by 24 is 0.208. 8 divided by 24 is 0.333. 6 divided by 24 is 0.250. And 1 divided by 24 is 0.042. So those are our 5 relative frequency values. So which class has the greatest relative frequency? Well, that would be the class from 62 to 66, because it has a relative frequency of 0.333. Which class has the least relative frequency? That would be the last class from 72 to 76. We were also asked to build a relative frequency histogram. So we can go ahead and take that information and choose one of these graphs below. So when we look at the information, we can see that the highest bar should be in the middle from 62 to 66. So which one of these graphs has its highest bar from 62 to 66? And the answer is graph C. And that's your answer.